Hey everyone, welcome and again, welcome at another Azure event today with Henry. Hey Henry.
Hi.
How's it going?
I'm fine, thank you. How about you?
Good. And really looking forward to learn more about Bicep because I have not been playing with it yet. So definitely interested. Old school ARM template user.
I can highly recommend it. I think I switched in November last year when it was still in preview and never went back. So I hope I can convince you today.
All right, very much looking forward. But before we do that, let's quickly thank our sponsors and partners for having these events. Especially in these COVID times, they helped us through getting the infrastructure and so on to do these streams. And they will also help us have an actual in-person event again in December. We don't have an agenda yet, but the idea is to meet up in Mechelen in Belgium, have an in-person event with 3 sessions. And please help us build the agenda. If you have any sessions that you would like to present, or you know someone who might be interested in presenting, head to the website and submit your talk and help us out there. And with that, I think, Henry, now is the time to actually dive into Bicep then.
All right, thank you. So good afternoon, everyone. Thank you for having me on the show or on the event. My name is Henry Been, and I will be talking to you, I think, for about 45 minutes to an hour about infrastructure as code for Azure. Using Bicep, the new and improved domain-specific language that is here to replace ARM templates, as Maarten already indicated at the start. If you're wondering who I am Henry. I'm from the Netherlands. So speaking in Belgium is always a privilege for me. I know that we don't always have the best reputation. We might come across as rude. I really apologize for that. I will do my best to behave as a guest in our southern neighbors. If you have any questions or remarks or whatever, feel free to reach out to me. My contact details are on the screen and they will also be on the last slide. One of the things that I do besides my work is that I have written a book and I'm working on the second one. And that second one will be about Azure infrastructure as code using native Azure tools. It will be a book about ARM templates, but also about Bicep lang, template specs, and all the other goodies that are part of the Azure Resource Manager ecosystem. It will be published by Manning, and if you're interested and you want to get it in the early access program with a big discount, you can use the code at the bottom of the screen to order it already. But today, we're not talking about the book, we will be talking about infrastructure as code for Azure. And the goal of today's talk is basically to help you take a good hard look at this portal and never use it again. When you start using cloud infrastructure, these portals are very handy to get started, to build the infrastructure you need to deploy your code on. But as you progress and build larger infrastructures, and maybe start working with multiple environments like test, acceptance, production, keeping up all that infrastructure and maintaining it manually becomes very tedious. So no more clicky click. Instead, we will be talking about infrastructure as code. The practice of writing the infrastructure you need, so what you see on the right, using something that resembles code, text. And the example you see here is already a Bicep template. But before we dive in, let's very quickly look at why we would want to adopt infrastructure as code. One of the problems that infrastructure as code helps you overcome is configuration drift. And if you have worked in IT for a while, you probably encountered this problem. If you have multiple servers in an infrastructure that get added over time, it's very likely that they all have a different configuration. Or maybe one of your servers in production, it breaks down and you restore a backup with a previous configuration of the server. The problem of configuration drift is that the configuration between servers start drifting and that one server might start behaving differently than another. And that's all the consequence of having to manually keep track of the state of our servers and update them and try to do the same thing on all servers manually. It's very difficult. But if we do it through code, we describe in code what our service should look like, and we deploy that, the automation takes care of doing the same thing over and over again. And these servers do not drift apart in configuration. Another benefit is that infrastructure as code can help us create infrastructure environments very quickly. For example, if we want to have a fresh test environment, instead of having to go into the portal and click together all the things, maybe look at our existing infrastructure to see what it should actually look like, you can recreate mirrors of your infrastructure very fast. It is even feasible to create a new environment for every separate test run. You will also get repeatability. If I use infrastructure as code and I make a change to my infrastructure definition and I deploy that to test, and I want to be very sure that I deploy the same changes to production to ensure that I get repeated results on production from what I've seen on test. Doing that manually brings in the error of making a mistake manually. If I do that through automation, I get a repeatable outcome between environments. Now, all these things, and especially the fact that the changes are now code instead of someone clicking in the portal, makes that it neatly integrates with our DevOps practices, with things like CI/CD. We can review our code, we can lint our code, we can even test our infrastructure as code. We can do reviews, impose change management, all the things that especially bigger companies enjoy. Like I said, this is one of the reasons that infrastructure as code, cloud development, and DevOps kind of come together and work really, really well. All right, I hope I've sold you on the idea. So let's take a look at infrastructure as code for Azure. Now, up till the start of this year, infrastructure as code for Azure was written using ARM templates. And probably a lot of the people in the audience have already encountered ARM templates in one way or the other. But there were some concerns around ARM templates. So now we have a replacement. And those are Bicep templates or Bicep line, kind of depending on who you talk to. And what I want to do next is, well, first, let's take a look at the differences. If you've seen ARM templates before, this should probably be very familiar. If you haven't seen ARM templates before, this is a minimal ARM template that you could use for creating a storage account. The first thing you will notice here is that it's a JSON file. And that's one of the fundamental choices of an ARM template. The whole template is a JSON object. It has a number of properties, it has a schema, it has a version. Hopefully that's kind of self-explanatory. And then you get a resources array. Here you describe the resources you need. For example, in this case, a storage account. You specify some of the properties that you probably recognize from the portal. Now take a few seconds to look at this JSON. What do you think of it? Well, if you ask people that worked a lot with ARM templates, they will have a number of observations. First of all, the JSON notation is very verbose. There are quotes, commas, and all kinds of, noisy things all over the place. And they distract from the things that you really want to look at. Another thing is that as JSON was chosen as the language for writing a template, things like functions or expressions had to be embedded in that JSON. And that resulted in quirky solutions for some things. For example, a function call or expression was hard to read that way, and don't get me started on conditions or loops. And all of that made that the templates became really, really hard to read, especially when you started building larger templates. Now, there were two ways that Microsoft could address this, or actually three. They could just discontinue, they could try to improve, or they could create a completely different new thing. I know they contemplated the last two for a while, but at some point, the improvements that you could do within the JSON format were at an end. So instead, they introduced a new language, what's called a domain-specific language, a new language designed to solve a specific problem. And it's called Bicep. And Bicep is a play on the word ARM, which is the Azure Resource Manager, which leads to ARM templates. Now, it has a specific syntax for solving the specific problems that come with declaring and creating Azure infrastructure. It is denser. You will need less characters, less lines to create the same things. You can leave out some things that you just repeat over and over and over again. And all in all, that makes them much easier to read. Just let's go back. settle this in for a few seconds, and then look at this. This is precisely the same definition for a storage account as you saw before, but this is Bicep instead of an ARM template. And I hope this shows you why I really like Bicep templates over ARM templates. And actually, I've been working with them since November last year, when they were still in preview, building a solution for a large customer that didn't have to launch until the start of 2021. So I gambled on Bicep because of how much I liked it. Now, let's assume you write a Bicep file like this, and you want to transform that into infrastructure in Azure. How do you go about that? Well, you have to install and download the Bicep executable and then execute Bicep /build / a reference to the file. This will take that Bicep file and transpile it into an ARM template, which you can then deploy into Azure. So you would create a resource group and then deploy the ARM template like you're used to if you've been working with ARM templates before. And this is how it worked until the start of this year. But since a version of the CLI, I think 0.22, but please don't quote me on that, the separate building is no longer necessary, but you can specify a Bicep file directly to be deployed into Azure. When you do that, it is important to understand that the transpilation from Bicep into an ARM template will still happen on your local computer. That will not be done in Azure. And you can see that because you can run az bicep build. So now the Bicep executable comes with the CLI. You can still invoke it directly. It's really handy if you want to quickly compile a file to see if it even works. And I should say transpile, really. All right, that's a lot of talk. I thought I'd do something exciting and something that I'm a little bit nervous about. But I'm going to try and create an Azure infrastructure in Bicep on the fly to show you the different things that you can do with Bicep. And if there are any questions or remarks, feel free to interject or ask them in the chat. Martin is monitoring the chat. Thanks for that. And he will relay any questions. So what you see is that I have opened Visual Studio Code, one of my 3 editors of choice, depending on the problem. Of course, I have some fallback files in case I screw up, but we're going to try and start creating something out of nothing. Now, if you want to deploy something into Azure, you can create resources that you deploy into a resource group, but you can also create resource groups that you deploy into a subscriptions into management groups into tenants. So the first thing that you can do in a template is define a target scope. So here I'm going to say the target scope is a resource group. That means I'm going to define resources that deploy into a resource group. I can also write subscription. Always filter first time around. Target scope equals. Thank you. I can also write subscription or resource group. And this is a domain-specific language and not just JSON. Depending on the choice I make here, my tab completion will change and more or less errors will be automatically detected by the editor. Now, I'm going to go for a resource group, and then actually I can leave this out because if you target a resource group, that's implicitly assumed if nothing else is specified. Now, let's assume I want to create a resource. And the resource that I want to create is an Azure App Service Plan. And actually, under the hood, that is called a Microsoft.web/server forms resource. That's the type of the resource. If we zoom in on that, this part is called a resource provider, and this part is called a resource. The final part that we specify after the @ sign is the version of the API for that resource provider that we're going to hit with our request in the end. We will learn about that more about that later on. Now this resource is going to need some properties. So I'm going to say equals, and then I'm going to open an object. Now this stays red because my resource is not valid yet. And this is something that you can already get for ARM templates a little bit as well, but for Bicep, the automatic validation is much more improved. So I need to specify a location. I get tab completion, and I'm going to specify West Europe. Completion here to add. Now, another thing that my server farm is going to need, it's going to need a name. So let's do something like demo HP. It still has a problem because I made a mistake. I'm sorry. My server farm. What I'm doing here is first I say I'm going to create a resource and I specify the type and the version, but I also have to put in a reference name. Within my template, and only within my template, I can refer to this resource under the name my server farm. We will see in a bit how that works. The name that I specify here is the name of the resource that will be created in Azure. Now, while there are no errors detected anymore, I know, because I prepared this, I also need to specify a SKU, which is basically how much I want to pay for my app service plan and how much performance I'm going to get. So that's a property, which is an object, which contains another property called name, and the value is B1. I've now created a server farm, or an app service plan. So let's do AZ group create. This creates a resource group with the name Bicep demo right here. What I'm going to do is I'm going to take this Bicep template and I'm going to deploy it into Azure. So what you see here is AZ deployment, which means resource deployment from a template. It's going to target a group, and I'm going to create a new deployment. I specify the name of the resource group that I want to deploy to, and I specify a reference to the file that I want to deploy. Now at the end, I can specify a deployment mode, and we'll talk about it in a bit. I could have left it out for now. Now this file is picked up, it is transpiled into an ARM template on my local computer, and that template is submitted into Azure. And if we open the portal, we hit refresh, we now get the resource group, and we got my resource. Much faster than using the portal? I don't know, probably not. But just imagine doing this with 3 environments, and Bicep would probably have already one. And from here on, we can start expanding our infrastructure. For example, I can now create a new resource, which is going to be my app service itself, which is of time Microsoft Web Sites. Too far, but what you see is that I get a pretty good search algorithm into all the different types of resources available. Tap completion on the latest version of the API. Time to specify some properties. Now, one property that I'm going to need here, again, is the location of the resource. This is repetition. I'm a developer. This itches. So let's go up here and say, I want to create a variable called location. And I'm going to specify the value as Europe. Take this variable and I put it right here and right there. One thing to note, if you're coming from ARM template, no square brackets, no quotes, no square brackets, no calling a function called variables, whatever, just directly reference to the thing location. Another thing an app service needs is a name. Let's call this demo HP. The name has to be unique because it translates to the URL for your app. The final thing that I need here, I think, is that I need to reference the server farm that it deploys on. Now, if you did this in ARM template, you would write a very long expression trying to get the full ID of that server farm. Here, I'm going to use that reference ID I talked about before. So I'm going to reference my server farm and then get its ID. Save this, redeploy, and now my app service will be created as well. It's going to take a few seconds, so let's do something else in between and look at another trick that you can do. Resources in Azure are grouped into resource groups. And one of the things that I often do is I group the resources into a resource group based on their life cycle and their deployment location. So in a lot of times, it makes sense to have the location of the resource derived from the location of the resource group. Luckily, there's a function that we can call, which is called resource group, which gives me all kinds of properties of the resource group that this template is deploying to at deploy time. name, tags, also its location. Where are you? Right there. So instead of hard coding the location for the resources, I'm getting it from the location of the resource group. Let's save that. Of course, we're just getting started, and we just want to build trust in Bicep. So I'm going to refresh this. And I now see that my app service is created as well. So let's see what we can do to build out this infrastructure a little bit more. Let's assume that I'm going to deploy an application to this infrastructure, and it's going to run and get requests. And one of the things that I know as a fact of life as a developer is that something might go wrong and that I need to know what is happening. So I want to use application insights to get monitoring and logging information out of my application. Create a resource, my application insights. I want to refer to it in this template, and it's going to be Microsoft .insights and then components. The latest version. And the properties for this thingy are that I have to specify a kind, which is web, and I have to specify its properties and then application type, which is once again web. So I've noted this down. You will see later on where you can find these properties. One of the things that I also need again is a name. So let's call this, I don't know, I think the name has to be unique, I think as well. Location. There we go. Let's deploy it. Now, I've created application insights. But one of the things that I will need in my app service is a configuration setting called instrumentation key to ensure that the code running on my app service can actually emit its values to that application insights workspace. So we need to do two things. First of all, we need to declare resources in my app service. And then secondly, we need to get that instrumentation key out of application insights. Now, there are a number of ways to go about resources that are nested within other resources. Deployment succeeded. Yeah, no errors. For example, we can put them below, and then the type will be, for example, Microsoft.web/sites/config. But what we can do also is nest one resource into another. So I'm going to say my settings, and that's a type config. I don't have to specify the full type here, just the part that needs to be appended to the type of the resource I'm nested in. The name for this thing has to be app settings. Depending on the name of this, just take from me, it has to be app settings. It's not something to go into right now. And now I can say properties, and here I can specify key value pairs with the configuration for my web app. So what I want to set is instrumentation key, and the value should be application insights. And again, I'm using a reference to the other thing declared in my template. Note that I'm referencing something below. That's perfectly fine. Order doesn't really matter. Azure will automatically decide on the deployment order of resources to make sure that application insights is provisioned before it's trying to get something out of that resource. And if you create a loop in your declarations, Azure will tell you in an unreadable and read way. From application insights, I'm going to need its properties and then its instrumentation key. There we go. And verify if we actually get what we need. So what I've done so far in 25 minutes is I hope I've sold you on the idea of infrastructure as code. I tried to explain what's wrong with ARM templates. So I think in 15 minutes, I have written an infrastructure that is good enough for running a very, very simple application. And I've also shown you how you can get secrets like the instrumentation key from one resource and put it in, for example, the configuration of an app service. Let me point out, by the way, that it's not necessarily a good idea to take secrets like the instrumentation key and put them directly into the configuration of an app service. Maybe you want to do an indirection using key vault, when you're running in the real world. But the principle of referencing works the same. And to babble on a little bit more while we wait on the deployment, I don't think Microsoft treats the instrumentation key as a secret. If you go to an application insights workspace, you can see it in plain sight. I would recommend treating it as a secret. All right, deployment complete. Let's refresh our Azure environment. There we have it, an application insights environment. That instrumentation key in plain sight. So now I need to remove this right after this demonstration. But what we can see as well, if I go into my app service and I find its configuration, I can see that this setting has been set automatically. There we go, no mistakes. Awesome. So this is where if you were using ARM templates, you would have written a 2-line expression to get that instrumentation key from application insights into the app service. Here it is much, much easier. So we've created some resources, we've nested some resources, we've taken stuff from one resource and reused it in another. Let's look at another syntax thingy. Another thing that I can do is declare parameters. Parameters are things that have to be passed when deploying the template, and I can use in the template to parameterize the deployments. And a very clear example that I hope everyone can relate to is, for example, the environment name that I want to deploy to. I always confuse the order of this. Now, whenever I deploy, I have to specify the environment name, but I don't want people to be able to, use whatever they feel like. I want to specify that they can use, for example, test or prod. I have this. Maybe I want to append that to the resource name. So here I want to maybe do environment name. This is the syntax for string interpolation. Dollar sign, curly braces, and then you put in the name of something. That's declared a parameter, a variable, but it can also be, for example, application insights properties. I can type any kind of expression that I want here. In this case, I'm going to postfix the names of all my resources with the environment name. So let's do that, except here, because this is a nested resource. And while it runs, let's say I want to deploy my test environment. Let's talk a little bit about what the mode complete at the end here does. Normally, when you leave this out, you hit a deployment mode called incremental. And that means that Azure is going to look at your resources in Azure. It's going to look at your template. And everything that's in your template, but not in Azure, gets created. Everything that's in your template and in Azure, but whenever there's a configuration difference, gets updated in Azure. When you specify a complete deployment mode, the same thing will happen, plus it will take a look at Azure and will remove all the resources that are not in your template. So that's very powerful, but also a thing, that can go wrong. Especially when people also make manual changes in an environment, maybe deploy things and add things, your first deployment is going to remove those things. So this is a two-edged sword. But in this case, all I can hopefully demonstrate is that I refresh the listing of resources in my resource group, that all of these are gone, and that 3 new ones are created. So it's still running. What we see here is that it first creates new ones, and then removes the old ones. Here we go. We can almost watch it live. Very cool. There we go. I think it's complete. All right. So let's think a bit about our infrastructure. We can run a web application. We can have it send log entries, and we can gather metrics from our application. Let's say we got the idea that we also want to, get an alert whenever there is a field request. Now, I prepared this resource. I hope you can forgive me that I'm not going to type this out on the fly. just going to zoom out a little bit so that it fits on the screen. A metric alert, or any type of alert in Azure, is a resource in itself. And that means that I can declare them in my infrastructure as code. And that's what I'm doing here. I'm creating a resource of the type Microsoft.insights/metric alert. There's a configuration here that specifies, for example, which metric I want to alert on which condition, namely that the request/field is greater than 1 for every window of 5 minutes, and evaluate that every 5 minutes. And that metric it should find in my application insights instance, which I should reference. This creates an alert rule in Azure. Now, let's assume that I don't want to alert only on field requests. I also want to alert on field dependency calls. Pick up this code, copy paste it. I'm going to call this my dependencies failures. Dependency failures here. And then, of course, I'm going to call it dependencies. Here we go. And I can deploy this. Environment again. Now, my infrastructure will not be changed because there are no differences, there's no drift, but these two alert rules will be added. But if you look at this, this code, let's assume that I expect things to go wrong in my test environment every now and then, just because it's a fact of life, not because I want them to. But I don't want to get called out of bed at the middle of the night. So I want to disable my alerts on my test environment. I only want to have them in my production environment. So what I can do here, I can add a clause which says if environment name equals, it's very dangerous because if I now create a third environment, prod2, I will have no alerting. So let's invert this and say if it's test, I don't want it. Now this alert will only be created in every environment that's not called test. I could do it here as well if I want to. But looking at that, there's another itch I need to scratch. I have copy-pasted so much code. Well, essentially, everything is almost the same. So what I really want to do, I want to maybe have a list of the differences between the alert rules somewhere and then deploy the same thing a couple of times. So I can go about that in 2 steps. First, I'm going to look at the length of the file, and that concerns me a little bit as well. So what I want to do is I want to describe this alert rule in another file and then pull it into this context. So what I'm going to do, I'm going to remove the rules, and I'm going to show you another file that I prepared. It's called metric module. What this basically does, it has the same alert rule, but all the things that are specific to my environment or to the alert, I replaced with a parameter at the start of the file. And this is a correct and valid Bicep file in itself. I could deploy this independently, but I don't want to do that. Instead, I want to reference that file or put it into this template, what you want to call it. So I'm going to say that I'm going to use a module this time, not a resource, but a module. And I'm going to call it my alert rule because I use these terrible names all the time already. Now, instead of specifying a type, I now have to specify a file. And of course, I have to specify some properties for it. Now, you might kind of expect that I would see the parameters that I declared at the top here. I shouldn't point. I apologize. You kind of expect that these may be here. But that's not true. Because underwater, what the transpiler will do, it will generate what's called a linked deployment. It's one template deployment triggering another template deployment. And that template deployment in itself needs a name as well. So I'm going to give that the name my alert rule deployment. This is not the alert rule, it is the deployment that deploys the alert rule. From there on, I can say params, and now I can specify the values for the parameters inside that module. So my application insights ID is going to be my application insights ID. My metric name is going to be field requests. My metric identifier is requests/field. And my threshold is going to be 1. I apologize for this JSON reflex that just kicked in. So I'm going to remove these commas. Now, if I deploy again, and just for the fun of it, deploy to production, it might take a while because it's, again, going to create resources in Azure and it's going to toss the old ones out. But what we should see is this expected result of an app service on an app service plan, application insights, and a monitoring rule. So I've pushed that monitoring rule into a separate file. But remember, we wanted to have 2 of them. So what I'm going to do, I'm going to create a list of the differences between the alert rules. So I'm going to say alert rule definition, which is a variable array that contains a number of objects. I'm just going to take this, put it here. And the second one I want is field dependencies. Dependencies/field. I kind of want to use this module twice. Luckily, there's a syntax for that. And if you're familiar with Python, this looks a lot like Python comprehensions, what I'm going to type here. I only know that because I did 2 evenings on Python on a programming contest and never used Python again. So what I should do for alert rule definition in alert rule definitions, I want to do the following module. I know there has been a hefty debate on where the closing square brackets should be, but they're here. Errors go away. Now, if we hover my alert rule, too bad. The first thing, I need to go through this and update this with the correct values, right? So, for example, the metric name is going to be alert definition dot metric name. And here, alert rule definition is treated as an object of which the properties are unknown. It's not really true because it's defined a few lines above, but the interpreter doesn't know. So I have to type this myself, at least the property names. So that's metric and alert rule definition threshold. Application insights ID is the same all the time. There's a thing that I need to change as well. The name of the deployment has to be unique, at least within the scope of the full deployment. So here I'm going to, again, use string interpolation, and I'm going to say, it's a good name. Let's use the alert definition dot alert rule definition dot metric name. Push this out into Azure again. So let's redo prod. And this should create the infrastructure in Azure that I need. And remember, I mentioned these linked deployments. Let's see what that looks like in Azure. If I go to my resource group, I can go to deployments. And what you see here is that my my demo deployment is running. So I click it. Oh no. And what I see here is that it deploys the resources I need. But this is not a deployment of a resource. This is the start of another deployment. So I can click it, and then I can get the details of that deployment if it were successful. So now let's see if I can pull a Scott Hanselman and fix this on the fly. Okay, so the name that I chose is invalid because there can't be spaces. Okay, I should be able to fix that. Wow. I'm going to cheat a little bit. This is not what I would do in the real world. Hopefully we will get a successful deployment now to my production environment. This will take a few seconds. But meanwhile, we can go into the Azure environment again. And here we see again that my demo deployment is running. The first alert rule has already been created. So by now the second one is also created. I can go in. And here I still see, yeah, here we go. It's refreshed. And I see that all the parts of my deployment has gone correctly. It'll take a few seconds to wrap up, but hopefully when I count to 5, 4, 3, 2, 1, it completes. And okay, I hope you'll take my word for it. Because in the interest of time, let's go back to slides. But I hope this has given you a very good insight into how very easy and quick you can work with Bicep templates once you've gotten the hang of them. And also how easily you can reuse the same template between environments, and how you can create partial deployments of templates that you can reuse. And if you have been working with ARM templates, trust me, this is fantastic. All right, let's go back to the PowerPoint, this one, of course. So I hope that's been enough demo. To quickly recap what you have seen, in the Bicep template, you can declare variables, var space name equals value. You don't have to specify type, automatically derived. You don't have to specify your variables at the top. You can specify them very closely to the place where you're using them, which is great. You can use parameters, things that you want to use in your template but differ between deployments. Parameter values you have to specify when deploying the template. You can use things like allowed value or default value, and there is more synthetic sugar there as well. One thing that I haven't demoed, but it's good to know about, is that you can create outputs where the result of a deployment is available to its caller. So if a module, for example, can create an output and give it back to its caller, or a template can generate an output and give it back to the command that executed it. I feel bad that I didn't weave that into the demo. So let's assume that I need the identifier of my alert rule. Let's assume that I want to get the ID of my app service plan of this deployment because I want to change this Bicep into another Bicep. I am going to say output app service ID, and it's going to be a string is my app service .id. And while we're at it, let me point out one more thing. Parameters, variables, resources, and modules, they all have a reference name. And these reference names share a single namespace. So I cannot do var my alert rule is bug because it will give an error. However, outputs use a separate namespace. There's been a lot of debate about whether this is smart, but it's really great that I can just generate something here or derive something here and then return it with the same name as that I referred it to in my template. Those are outputs. You've seen functions, you've seen the resource group function. There are tens of functions that you can use, and there's a reference where you can look them up. And the final thing that's really powerful in Bicep is that you can get the value of a parameter or a variable of properties of resources using their reference name and access the values directly. We've also seen the more advanced things like modules, pulling in another existing in itself valid Bicep file to become part of your deployment. You've seen how you can loop over an array or something you retrieve or something you receive as a parameter and deploy similar resources in parallel. And finally, you've seen how you can leave resources out of certain deployments or include them or vary a property depending on an expression. But a word of caution here, introducing loops and conditionals in your template can conflict with repeatable outcomes. You make the deployment of your template less deterministic. And that means that, for example, if you only enable some things in production and not in test, let's say a security measure, everything can look good in test, but in production, nobody can access your application because all of a sudden a certain firewall is in front of the application and you forgot to open the correct port. And I'm just making this example up, but think about this when introducing loops and conditionals. Now, I'm always tempted when I give a presentation to not just only show something, but also try to teach something. One of the things that you should know when talking about templates is that ARM templates and Bicep templates are just another way for interacting with the Azure control plane, just like the portal, PowerShell, the CLI, or whatever. And it's the same control mechanism that's behind all these input mechanisms. And everything in Azure you can manage using ARM templates, Bicep templates, or these API. Everything is a resource in Azure. IP addresses, dashboards, alert rules, activations, findings in Security Center, configuration for Security Center, you name it, it's probably a resource. And all the interactions with resources are either on the control plane or the data plane. The control plane is creating, updating, configuring. The data plane is, for example, putting data in a database. And all the interactions with the control plane go through one interface, which is the Azure Resource Manager. But your resources in Azure, they're grouped according to the resource provider, the piece of software that manages creating, updating, configuring, and monitoring the health or whatever of that resource for you. And these resources providers, they are aligned with the different teams in the Azure organization, writing the code to do so. And I, as a user of Azure, don't want to know how to interact with all these different APIs. And that's where the Azure Resource Manager comes in. ARM is a unified RESTful API that can take requests on my behalf. And depending on the correct resource provider and the correct resource type, it can relay it to the resource provider. And this unification of all these things makes that I can interact with one API through the portal, CLI, SDK, and HTTPS. But it's also the basis of how templates work. Because when I write a template and give that to ARM, under the hood, it will do GET requests to all the resource providers to get the actual state in Azure of my environment. And then it will compare that to the different resources declared in my template. And it will decide what to remove, what to update, and what to create. So it will generate put, post, and delete requests. It will decide on an order. So ARM is the thing that glues my templates on top of that RESTful API and interacts for me with the resource providers. So if you know about this, one of the things that you will notice is that all the resources in Azure can be addressed using a unique ID. And you've probably seen that already in the URL when browsing the portal. But when you're working with ARM templates or Bicep templates, it's good to understand a little bit of the structure behind your templates to see how you can address a resource. So every resource has a URL like this. management.azure.com/subscriptions/subscription ID/resource groups, resource group name, providers, provider name, and resource type and resource name. A concrete example would be what you see here at the top. This is the unique ID of a service bus namespace. And I can really put the JSON that you see here to that URL, and that will result in a service bus namespace being created. And a few seconds later, I can put a GET request on that same URL, and then I get all the details of my service bus namespace. This is what ARM does under the hood after I submitted that template. I thought it's just wise to share a few things with you about how ARM worked. One of the things that might have gotten you a little bit dizzy during this talk is all these properties that you've seen in the ARM template or in the Bicep when typing. I want to point out that there is a very good reference where you can find all the properties. You can go to, let me show it. I can go to ARM template reference. I have no idea where the URL is. I can find it. And let's say that I want to create, I don't know, storage account. I want to there are too many things called storage. Let's say I want to create, I don't know, an app service, working server farm. I can go to web and then to server farms. And here I can find an example of the properties that I can use for creating a server farm in both Bicep and ARM templates. And I get a detailed description of all the properties, which type they should be, which values are allowed, what they do, etc., etc. Keeping this reference next to you is very handy when you're working with Bicep. Now, I was kind of planning on talking to you a little bit about policy, Azure policy as well, but I'm going to skip that for the sake of time, because I really hope you enjoyed this introduction into Bicep. I was a little bit nervous about doing all this live coding, so I hope it worked out. And I will save you from this animation and turn it back to Maarten to see if there are any questions.
Absolutely. I forgot how StreamYard works to bring myself on screen again. Yeah, thank you. I definitely learned. And yeah, like I said, I was curious about this. So this is definitely a good introduction. So thank you for that. There are actually some questions as well. I think the first one you already answered in your last section of the talk. Can Bicep be used to apply deltas to existing resources?
Yes, absolutely. So if we do take a look at this picture, whenever I submit an ARM template to the Azure Resource Manager, because that's still what you're doing when you're working with Bicep, you submit it and it comes into ARM, and ARM will validate it as much as it can. Is it structurally sound? Is it valid? And then it goes through a number of steps. It will validate if you have the correct authorizations to do what you want to do. It will check if there are any policies keeping you from doing what you want to do, if there are resources locked. And then it goes into provisioning the resources that you declared in your ARM template. It can either create resources that you specify, or it can update resources that are already there. And that's why it's important to know about this ID for a resource. If the ID of a resource in Azure matches the ID for a resource that you're specifying in your ARM template, the configuration in your ARM template will rücksichtslos override the configuration in Azure.
That answers the question, I think. The other one is also another one that is quite into Bicep. Is there an easy way to switch the target scope in one file, or is using modules just the easier way?
I do know that the property scope has been surfacing on some resources lately. For example, if you deploy to the tenant level, I think you can more easily create management groups on different level in the management group hierarchy. I am not aware of a way of changing scope halfway a template. So I would always do indeed what the question asker suggests, is I would use the property scope on the module deployment. And then, for example, I can go to my subscription, its ID. And then, of course, this has to be a template that targets the subscription. That's possible. Or I could say resource group, and I think, there you go. I can leave an resource group. And this will deploy that module into a resource group that's in the same subscription as my current subscription. So basically my sibling resource group. I think that's the best way forward, at least as far as I know.
All right, that's clear, I think. An interesting one, and also coming from the ARM background, I think it's one that I will love the answer for. Are there any things that you can do in ARM that you cannot do with Bicep?
I think it's still not possible to create custom functions in Bicep. That's one of the things that I know that was possible in ARM template and hasn't been in. I apologize. So that's what happens when you. Are the client. There's nothing else that I can think of, really. But of course, I have a limited view of the world, and we're talking Azure, so nobody can know everything. But nothing that's holding me back.
All right, then why not all switch to Bicep, right?
I recommend it wholeheartedly.
Cool. Maybe one other thing, because if I'm switching, I might also switch to use Terraform or Pulumi. How does Bicep relate to those, and when would you use one or the other?
So I think, first of all, it is a matter of personal preference. Some people might pull the term best practice. I'm not a big fan of that term. Best practice is often something that worked in one context, and then we try to reuse in another context where it's not necessarily the best choice. But to really answer the question, one of the benefits that the Terraform brings is that it can target multiple environments, target platforms, Bicep is so tightly integrated with ARM, it can only target Azure right now. Terraform is built on the idea that you can bring in different providers, so you can target Azure, AWS, GCP. But for example, you can also use Terraform to create a VM and then carry on to configure the Linux VM or Windows VM you created. So it can just target multiple platforms. So that's a pro. Another thing that differs Terraform from ARM is that Terraform works with a state file. So Terraform is going to keep a cache of everything you've got in Azure, and it's do this comparison on what to create, what to update, or what to delete between that state cache and your definition. And it's going to write directly into Azure, depending on the decisions it makes on its own. That way you can more easily do simulations. Your deployment might be a little bit quicker because ARM doesn't have to do all the gets for you. But if your state goes out of sync with the actual state in Azure, that might be a thing. Another downside of Terraform, in my opinion, so this is very opinionated, is that it is yet another tool in your ecosystem. And if you're working in an organization, you will quickly note the number of tools and technologies and how quickly they ramp up and how much people have to know. So if I can remove one thing that people have to know besides the thing that's more natively related to Azure, that will be a consideration for me. Now, Pulumi has a different take on infrastructure as code. You really write it as C#. It gives you objects that you can write unit tests against. But again, it is another tool that you bring into the mix, and probably one that fewer people are familiar with than the native tools. But that might be my personal bias. I do know that Pulumi is growing very hard. It's getting a lot of traction. So I would never recommend against any of these three options. And there are just considerations where one would fit better than the other, I believe.
Cool. Yeah, I also saw in the comments someone was mentioning that Terraform typically is a little bit slower in catching up with newer Azure APIs. And I think Bicep, being from Microsoft and very Azure specific, is probably better in that regard as well, if you want to use the latest and greatest that is coming out there.
That used to be true, but I think that both Terraform and Pulumi now did a thing where they get the API definitions out of Azure itself, so that it's almost nearly up to date. But please, again, I'm not 100% sure.
All right. Yep. With that, I don't see any new questions coming in. Lots of positive comments and thank yous and all that. And same thing from me and from Azure. Thank you for presenting. Thank you for taking the time. And everyone at home, thank you for joining us today and yeah, being here, asking good questions and all. Cool.
Thanks for the invitation.
All right. Do stick around. I'm going to end the broadcast here, but just catch up afterwards. See you, everyone.